Hare Krishna. Hope you are doing well. Let's get started with this question primarily on functional analysis, but we will see towards the end that there are some trigonometric connections that can be our best friends for this question. So the question is giving us a function which is a continuous odd function, and then based on that another function is defined, and the question is all about the properties of that function, whether it's odd or even, whether it's periodic or not. So let's get started. We can start by investigating whether this function is odd or not. So essentially, this is the condition that an odd function must satisfy. So the idea is pretty clear. You start with g of minus x and see what you are ending up with. It has to be odd or even because the options are structured like that. So you will either guess minus g of x or just g of x. And it's simple. It's a definite integration game, honestly. When you put that minus x over there, you make use of the oddness, odd property of f and transform the variable. The reason I put this section in minding pitfalls is because of this minus sign, because when you are substituting this thing, the minus sign does come into the picture, but essentially it also goes away because f is odd, so minus f of minus u is going to be fu. Think about that. And that's why it could have been, if you did not deal with it, you would have ended up with minus g of x, which would have been incorrect. So that's why it's always a tricky area when we are dealing with this definite integrals where we have to change the variable with its negative. Okay, now let's talk about periodicity. Periodicity essentially means this property, which f is anyway satisfying. So that when the capital T is the period of f, which means that whenever you add capital T to the input, here it belongs to R, it's a real number, whatever it is, you will get the same in you'll get the same value of the function with the same input. So again, to investigate the periodicity of G, it's a good point to start with this thing itself. And when you go about this, you see that you can break the definite integration into two parts. Now, the thing to understand that this part is going to be 0. Why? Because if you see, look at it like this, minus capital T to plus capital T, ft of dt, this thing, it's a symmetric interval and f is an odd function. So when we integrate an odd function over a symmetric interval, essentially the two parts involved will cancel each other out and this would become 0. So minus t to t, this thing is 0, but this can also be written as 0t to ft dt. So this thing is also 0, which means essentially this thing is 0. So now we are remaining with this part, which when we look at, we can make use of the periodicity of f itself. When we just do some substitution over here, we take u as x plus t, then we can go forward with this. Sorry, here we are taking u as small t minus capital T, so that this t becomes u plus t and du is the same as dt. And when we have and the limits also get transformed accordingly. And when we have this, because of the periodicity, we see that this thing was there. So essentially, yes, it's even and periodic, and this is the way you get the answer in a competitive exam. Absolutely not. You actually, you could, but the thing is, it's a general question with a specific answer. Again, if you don't understand what I meant by that, you should watch the first introductory video to this series. And you should try to see what is that odd function, a simple odd function that you can think of, which is also periodic. And if this thing rings your bell, sin x, then you can just use this as the starting point and see what you are ending up with. And you will end up with, if you choose f as this, you will get g as 1 minus cos x. Now cos x is an even function. Any even function, what do I say, uh, plus minus a constant is going to be even still, and cos x is also periodic like sin x. So that would give you, I that's why I really like this. If you do the theory way, let's say you are fast, you could do it in a minute or so, but if you just are able to connect this dot, then 10 seconds, if assuming you are that fast over here, so you can do it in 10 seconds over here. So answering, if we can think of specific ways to answer general questions, easy specific ways to answer general questions, we should try to do that. That was it. Take care. Hare Krishna.